Welcome, geometry students, to Chapter 4, Section 9, last section of the chapter, Isosceles and Equilateral Triangles. Pause the video, try this, and come back and check your work. Okay, because we are given in number 1 that each side is congruent, we know that each angle is congruent. This is an equilateral or equiangular. The angles are 60, 60, 60. Every equilateral triangle is isosceles, true or false? True. Not every isosceles is equilateral though, right? And every isosceles triangle is equilateral. I just said false, right? You could have 2 congruent sides with a third side not being congruent to those 2, right? Today we're going to prove theorems about isosceles and equilateral triangles and apply properties of isosceles and equilateral triangles. So let's recall that an isosceles triangle has at least 2 congruent sides. The congruent sides are called that's right, the legs, right? We talked about that 2 days ago. And what is the angle formed by the legs? The angle formed by the legs is the vertex angle. Okay, so if you find the isosceles 2 legs, the angle between them is the vertex angle. The side that's opposite the vertex angle is called the, I bet you can guess, the base. That's right. And there are 2 angles that have the base as a side. They are called the base angles. Right. So in this isosceles triangle, we have the 2 sides that are congruent. Those are our legs, right? Between them would be the vertex angle, angle 3. Across from angle 3, we have the red side, which is the base, right? And the 2 angles that are on either end of the base are the base angles. We have theorems for our isosceles triangle. This theorem is about angles. Angle B is congruent to angle C. So it is called the isosceles triangle theorem. If 2 sides of a triangle are congruent, then the angles opposite those sides are congruent. And kind of the converse of that is if we know that 2 angles of a triangle are congruent, then the sides opposite those angles are congruent. So this is the converse of the isosceles triangle theorem. We can prove a triangle to be isosceles if we know that 2 of the triangle's angles are congruent. The isosceles triangle theorem is sometimes stated as base angles of an isosceles triangle are congruent. Some people might think that we only think about the legs of an isosceles triangle, but we could think of it this way as well. The base angles of an isosceles triangle are congruent. Okay, so the length of xy is 20 feet. Explain why the length of yz is the same. So pause, think about it, jot down your thoughts, and come back. All right, if you're back, we know that this angle we can call x is 40 degrees. And we know that this kind of exterior angle is 140 degrees. So what does that tell us about this interior angle z, interior to this triangle? It tells us that it forms a linear pair with this 140 degree angle, right? So we can say that this angle yzx, is 40 degrees. And now we know that this triangle xyz has 2 40-degree angles, which we now can call base angles for an isosceles triangle, right? And because we know this is isosceles, then the side opposite each base angle, the side opposite this angle z is 20, so the side opposite angle x would also be 20 feet. Okay, and that's by the converse of the isosceles triangle theorem. If the distance from Earth to a star in September is given by this expression, What is the distance from the Earth to the star in March? This question requires prior knowledge about the Earth's rotation. In September and March are how many months apart? That's right, they're 6 months apart. So if I have the sun here and we're going around the sun, right? I'll put Earth, let's say here. Earth is here. Let's say Earth is here in September. And then Earth is traveling around and Earth is here in March. Well, the star is somewhere way out here, and the Earth is the same angle from the star in September as it is in March. So basically we have, because of that angle, we have an isosceles triangle, right? And so we could now say that the Earth is the same distance from the star in March as it was in September, which is 4.2 times 10 to the 13th kilometer. And we can say that because they told us, or we know from prior knowledge, that this angle would be the same. The angle which tells us that this is isosceles by the converse of the isosceles triangle theorem. Okay? And that's how we're able to state that these legs are the same length. So more common questions for you will be given a diagram. So we're asked here to find measure of angle F. Measure of angle F down here. Okay, so let's take a look at what we're given. We're trying to find this, and it looks like we're given that this triangle is isosceles, right? So the angle opposite segment DE is what we're looking for, right? And we don't know the angle opposite side EF, but we do know angle E is 22 degrees, right? And what do we know about angles D and F? That's right, we know that those angles must be congruent, right? And we know something else about the angles in a triangle, right? They are their sum is 180. So let's go through this. We know that angle F equals angle D. So we don't know what the number of degrees is. That's what we're setting out to find, right? That's our isosceles triangle theorem. So we can say that angle F plus the measure of angle D plus the measure of angle, this should say E. This should say E is 180, and that is our triangle sum theorem. Isn't that funny? They've done another typo. And we can substitute, right? We know this angle E is 22, and we know that angles F and D are congruent, same measure, they're equal. And so we can call this substitution, right? And so now we simply solve. What would we do? We would subtract, subtraction property of equality. They probably just say subtract. Isn't that funny? And then we're going to divide, division property of equality. And we end up with x being 79 degrees. So the measure of angle F is 79 degrees. The measure of angle D is also 79 degrees, but that wasn't asked. Go ahead and pause the video, come back and check your work. What is the measure of angle H? And you should have found 66 degrees. Excellent. Don't forget to pause before you see these answers, right? Now we're given algebraic expressions, variable expressions for the angles, and so find the measure of angle N. Pause the video, come back. All right, so this is much like the previous two examples, but instead we have these expressions, right? And so let's see, we can start with, we know that the measure of angle P equals the measure of angle N, right? And that's the isosceles triangle theorem. We have symbols here that state this is a isosceles triangle, right? So we can now substitute, can't we? We can say that the expression for this measure of angle P equals the expression for the measure of angle N, substitution, okay? And now we could simplify this, right? We could collect our y's to the same side and isolate the y, right? And divide, now we're going to divide by 2, right? And we end up with the measure of angle, or not the measure of angle, but y equals 8. So if we want to know how many degrees are in angle n, we're going to substitute 8 into this expression. So the measure of angle n is 48 degrees. And so we actually could find all angles, can't we? Because we know that P is also 48 degrees. We can simply subtract those two from 180 to find measure of angle M. Here's our super special isosceles triangle. It isn't simply isosceles, it has a third side that is also congruent to the legs, and so we call this the equilateral triangle. So if a triangle is equilateral, then it is equiangular. I love that word, equiangular. Equilateral triangles are equiangular triangles. And so all sides are congruent and the angles are all equal to 60 degrees. Good. And so we can say that an equiangular triangle is equilateral, can't we? So if a triangle is equiangular, then it is equilateral. We can say all sides are congruent. We don't know the lengths of the sides unless we're given more information. We do know the angles are all 60. The lengths could vary though. Okay, let's find the value of x. We're told that triangle LKM is equilateral. So we know angle L is this expression. What can we say about angles K and M? We know that this equilateral triangle is equiangular, so we can say that 2x plus 32 equals 60 degrees, right? Because every angle in an equiangular triangle is 60 degrees. And now we can solve for x, simply transforming this equation. So we'll subtract 32 from both sides, subtraction property of equality, and we'll divide, and x equals 14. Very good. Go ahead and pause the video, find the value of y. Okay, if you've come back, we know that this equiangular triangle is equilateral by the theorem we just took a look at, right? And so we are now going to be able to say that 5y minus 6 equals 4y plus 12. And that's our definition of an equilateral triangle. So now we solve for y. And you should have y equals 18. Okay? Remember, a coordinate proof may be easier if you place one side of the triangle along the x-axis and locate a vertex at the origin or somewhere on the y-axis. So we're asked now to prove that the segment joining the midpoints of two sides of an isosceles triangle is half the base. The segment joining the midpoints of two sides of an isosceles triangle is half the base. So in isosceles triangle ABC, x is the midpoint of AB and y is the midpoint of AC. So prove that xy equals half of AC. AC must be the base. Okay, so we can draw that in a coordinate plane as we were doing yesterday, and we can even place a vertex at the point of origin. So we are able to use our midpoint formula to find the coordinates of x and the coordinates of y. Remember, the midpoint formula is simply add the x values for a segment, right, of the endpoints of the segment and divide by 2. Add the y values of a segment, the endpoints of a segment, and divide by 2. Okay, so we can find those. There we go. And we're able to then use the distance formula to find the length of xy. And the length of xy would be the square root of 4a squared, which is 2a. we know that AC is 4A, and so we can say that XY, 2A, is half of AC, which is 4A. Please try the lesson quiz and come back and check your work. All right, if you're back, the measure of angle R must be 28 degrees. The measure of angle P then is 124 degrees. And we have this equilateral, equiangular triangle, and we're trying to find x here. X equals 20. 80 minus 20 is 60, right? And in this case, we're trying to find y, and y equals 6. And this one, the answer was uncovered. So you have it. Okay, how about here? The vertex angle of an isosceles triangle measures a plus 15 degrees. And one of the base angles measures 7 times a, 7a degrees. Find a and each angle measure. Pause, come back and check it out. Okay, and you should have found that a equals 11, so we have base angles of 77 degrees, and the vertex angle is 26 degrees. If you need to draw a picture, definitely do it. It's worth it. And your assignment, where's your assignment? Here's your assignment. Have fun.